Hello and welcome to episode 35 of the HamCorp training manual. In this episode, we will start the process of centralizing our power generation and storage. To help with this, we will automate both silicone rubber and styrene-butadiene rubber, as well as lubricant. And our benzene continues to go down. So my goal is to centralize our power generation, and I noticed that our benzene production is not at 100% uptime. If you watch this distillation tower, after this craft is done, it takes some time for the wood tar to build up again. So to make wood tar faster, we just need to increase the speed of our pyrolyze ovens. We can do that by overclocking, which is a bad idea because it cuts into our power profit. We can make another pyrolyze oven, which I may end up doing. There's another way to increase the output of these pyrolyze ovens. If you see the description here, it says processing speed scales linearly with coil tier. And currently we have Cantal coils, and that's 100% processing speed. So I made some nichrome. And now this should run 50% faster. And it does. This craft now takes 21 seconds instead of 32 seconds. Now hopefully we make wood fast enough to keep up with this new processing speed. But I'm going to keep an eye on this distillation tower and see if it is at 100% uptime, which, I mean, clearly it's not. So I think I do need to make another pyrolyze oven. And I might even make some more fluid extractors here because these are starting to fill up. Well, we're making 50% more charcoal per second now, so 50% more fluid extractors should be able to keep up with it. I could also take this opportunity to clean up these pipes around here and maybe switch to Ender IO pipes, or conduits rather. Alright, actually I've checked some math. To have the distillation tower run at 100% uptime, we're going to need 4 more pyrolyze ovens. Which is possible, but I don't really want to do that. So instead, I've decided I'm going to leave this as it is, and I'm going to switch to using cetane-boosted diesel. So the benzene setup is going to power itself, and it's going to power the cetane-boosted diesel line. I haven't done the math to check if that's sustainable, but I'm just going to keep an eye on the console and the control tower and make sure the numbers aren't going down over time. We have a pretty big backlog of these two liquids, so we have some space to do some empirical testing. But that means I need to connect the oil refinery to the Applied Energistics network, which has not been done yet. And that leads to our first problem, because if you see this dense smart cable, it has 8 channels in it. And the rest of these cables are all regular cables. So these are all maxed out. Well, at least until this junction, it's maxed out. And I don't want to replace everything with smart cables. That's a lot of circuits, and it's not really worth it. So I need to make dense covered cables. And dense covered cables need styrene-butadiene rubber or silicone rubber. So there are 2 quest lines that I want to deal with. I could do either one, but I want to do both for the sake of the quests. So let's start with silicone rubber. This is made by combining sulfur and polydimethylsiloxane pulp. There are a few different ways to make this pulp. The quest recommends this method, and I'm going to do that for the first batch just to finish the quest, but my final setup is going to use this recipe instead. Large chem reactor where you just chuck in the silicon, methane, chlorine, and water, and you just get the final result, which is pretty nice. You also get some hydrochloric acid and diluted hydrochloric acid. But this turns everything into one single step, and that's just really convenient. So this is the setup I'm going to do for actual production, but let's do the quest. And here it is. Silicone rubber automated. Before I run you through the silicone rubber process, let me just tell you a couple of new things in here. For example, the chemical plant now has a subnet. It's set up very similarly to the ore processing subnet. So this subnet can only see, of course, outputs of this area, and also only the inputs, because I've filtered the interface here. So it's only sulfur dust and raw silicon, for now. And we're out of sulfur, but that's a different issue. I've also put down this high voltage battery buffer with 16 batteries inside. This is slowly running out because it has no input, but my plan is to send a wire down the shaft through the maintenance tunnels all the way to the power building, where it will be merged with our new centralized power system, which isn't done yet. And here at the brain, I have replaced these cables with dense covered cables. So this allows me to have more than 8 channels going out of this P2P controller. But okay, so silicone rubber. It's being supplied with raw silicon, it's being supplied with sulfur dust, it's being supplied with chlorine, and it's being supplied with methane. The methane is sourced here in the oil refinery as part of the refinery gas distillation. And the chlorine, yeah, I actually don't have anything set up for chlorine. I'm just kind of manually electrolyzing rock salt and just putting chlorine into our main net. So that is something that I need to address. And of course there's water going into this top hatch. As for outputs, this process outputs polydimethylsiloxane pulp that goes into this chemical reactor where it's combined with sulfur dust to make the rubber. The rubber is then solidified into bars. I want this to be my standard way to store these kinds of things, just as bars. Just so I can be consistent with all of my auto crafting recipes, so it's not half fluids, it's not half bars. It's just always you start with bars. If you need a fluid, you fluid extract it elsewhere. We also get diluted hydrochloric acid, which goes into this distillery, where it's very slowly distilled into regular hydrochloric acid. And of course we also get regular hydrochloric acid, which is directly put into the super tank. And then this super tank is visible to the subnet, and therefore also the mainnet, and it's set to void overflow. This isn't ideal. I can obviously recycle some of this hydrochloric acid to get the chlorine back, but at some point I'm going to have infinite chlorine, hopefully. But once I have infinite chlorine, it won't really matter if I'm voiding hydrochloric acid. I'm already voiding hydrochloric acid over here. And so that's our silicone rubber done. Now I said I want to do styrene-butadiene as well. This is a little more annoying because I need a steam cracker for naphtha. I do have naphtha at the oil refinery. It's not doing anything. It's just sitting in this tank. And originally I saved it to make polycaprolactam using this recipe, but I think it's fine if I use some of it to make styrene-butadiene rubber as well. So I'm going to get another steam cracker put down, probably in this building, and I might just put it over here. There's a little extra space. And I'm also going to need another distillation tower. So some more crafting to do. Benzene is not looking great. In fact, I am considering swapping out this power situation with benzene for the brain with cetane boosted diesel. I have made 4 turbo combustion gens, and all I need to do is hook up the cetane boosted diesel here. Actually, I could even do it with logistics pipes. I'm going to do that. HamCorp is sorry to inform viewers that we have been slacking on ore processing. We're not doing it in an automated way yet, and there are a lot of ores I need to process. I'm out of chrome, I'm out of nickel, I'm almost out of iron, so this is going to take some time to get through. However, switching off of benzene and onto cetane boosted diesel has seemed to stabilize these two. We're not gaining benzene, but we're also not losing benzene. But while I do this ore processing, I'm just going to spend some time at the farm back in this fucking place, and I'm going to try and... Whoa. Looks like shareholders don't want me here. But I'm going to spend some time at the farm and just breed up a bunch of crops, see if I can get anything new, see if I can get enough salty root to get an actual salty root farm going, maybe some more blaze reed. I should also automate the stick reed. I have stick reed, but it's not in any of the farms. So I'm just going to do some boring breeding work at the farm while I do this ore processing. I do have enough materials for the oil cracker. I just need 1,000 stainless steel for the distillation tower. So here we are, back at the farm. So I actually haven't made that much progress here because it took less time than I expected to get the stainless steel done. But I have 1 salt root. That's it. Also, I've expanded the building to another 2 farms, and then I'm also going to expand these steps up 2 more times. So 6 new farms. And then we'll have a total of 12, which is not a power of 2, so I'm going to have to make 4 more, probably another step. But that's something for later, because I have everything I need for the distillation tower and the oil cracker. There's the oil cracker. And now, are you ready to see some of the most cursed wall sharing I've ever done? Oh god, I hate this. I hate doing this. This is crazy. Oh, that's so weird. That's so weird. Oh, what have I done, bro? What? Ugh, I feel dirty. Like, it's one thing to share walls with the same machine. Like, if this was 2 distillation towers, that would be fine, but what is this? Okay, now I do need to set up some pipes, connect the gas turbines here. Also, because this whole thing is currently just using, GregTech pipes, I'll probably stick with that, at least for now. So I need to pipe over this naphtha all the way to the oil cracker, and then the lightly cracked naphtha will go into this input hatch. The pipes are in place, including the pipe that takes the cracked naphtha into the distillation tower. This is at a higher temperature, so I had to use potent pipes. For the next step, we need ethylene, benzene, and butadiene, all of which you can obtain from... I put the controller behind the tank. But all of which you can obtain from the lightly steam-cracked naphtha. Alright, this is now processing. We get a bunch of other stuff as well. More toluene, more light fuel, more heavy fuel. Yeah, I need to think about what to do with these. We have so many chemicals in here that I'm just not using. 2 cells of benzene, 2 cells of ethylene, and 3 cells of butadiene. Now for styrene, we just need to react benzene and ethylene. And we're also going to get some hydrogen out of this, which I am probably just going to void, like so. Well, actually I've obviously done a little bit more than just the styrene, so let me run you through this. This reactor makes styrene and hydrogen gas from ethylene and benzene, which are supplied from fluid export buses. Hydrogen is dumped from this output hatch into this trash can, and the styrene is in this output hatch, where it's sent directly into the input hatch of the next machine. So let me grab some styrene for the quest. And the styrene here, we combine with butadiene and oxygen to make raw styrene-butadiene rubber dust. That goes to the chem reactor. I need to hook this up with some sulfur. But when I do that, it will make the liquid form, which then is solidified into ingots, which are stored in this drawer. So we could also make polystyrene from the styrene, but apparently, according to the quest, you don't really need to do that, because you don't need a lot. So I'm just going to come back to this when I end up needing this, and I'm just going to make a small amount. As part of centralizing and increasing my power production, I want to start using this combustion engine. It's a multi-block, and it needs lubricant. So that's the next chemical I'm going to work on. It should be pretty quick. Yeah, very simple. Just combining oil like talc or soapstone or even redstone, and you get lubricant. Just in a brewery. Even an LV brewery is probably enough for my needs. I'll do an HV one anyway, but yeah, this is going to be pretty quick. And there you go, already done. So very, very simple. Just oil, redstone, and you get lubricant. That's it. Now originally I wanted to make the combustion engine, but what I didn't realize is the dynamo hatch is going to have to be an EV dynamo hatch, and the EV dynamo hatch requires tungsten steel. So that's an issue. We have 0 tungsten, and obviously 0 tungsten steel. So for now, I'm just going to rely on regular HV combustion gens, and I'm going to transform up into EV. And once that's done, I can start working towards our first tungsten steel. So I'm going to need more Lapotron crystals, probably, and also some transformers. So I'm currently crafting up some supplies for implementing the new power system. I also upgraded this crafting CPU to 4+1K, so it's 5K now. And I've set up a tiny little HV step-up transformer system here. So these 2 transformers are going to step up to EV and start charging this battery buffer. First, I obviously need to add some combustion engines. But then this battery buffer, I still have to make more Lapotron crystals, but this battery buffer is going to output into this cable, which will then go into the maintenance tunnels and throughout the base. However, I do want to place the cable in the middle of the tunnel, which means I need to get rid of these potent fluid pipes, which I originally thought was going to be a real pain, but actually it's not. The only thing that this thick pipe, the huge pipe, leads to is this buffer, and the only thing that this buffer actually supplies steam to is these 2 machines, this machine, and the logistics power junction. Now this I do need to keep powered still, So I am probably going to swap this out for benzene or cetane boosted diesel. And if these 3 machines are not powered, then I don't really care. So I'm going to switch the power supply for the power junction, and I'm going to remove this iron tank after so long. This has been here for a long time. But then I'm also going to get rid of the potent fluid pipes, and I'm going to make more 16x aluminum cables and start wiring this place up. I've moved over 4 turbo combustion gens. These were powering the energy acceptor that used to be at the brain. I've moved it over here. I'm gonna pretty this up at some point, make this look a little bit better. But right now, this cable isn't connected to anything except for this energy acceptor. So it's 1542 EU per tick. Yeah, pretty expensive. Now, I really want to switch off of logistics pipes. So I think I'm going to spend a bunch of time redoing and potentially upgrading these chemical lines at the chemical plant. Because right now, this half of the building is applied energistics, this half of the building is not. And there's some important things here like polyethylene and polyvinyl chloride. And I have them stored as liquids, but I want to store them as ingots, like I mentioned before, to just have everything be kind of standardized. And of course, I also want to connect this power supply to the power station. I'm going to need a lot more cables for that, so there's a bit of a wait. And in that time, I'm going to start moving these things over. Thank you for watching this episode of the HamCorp Training Manual. In the next episode, we will continue rewiring the base one building at a time and continue progression in EV. Specifically, we will work on improved circuits and obtaining our first tungsten steel. HamCorp recommends that all employees who are committed to increasing quarterly profit forego their salaries until our goal is reached. See you next time.